So this is having an angle. This is mg sin theta. You can resolve this also as before. This is in the direction of mg only, no?
Yes, sir.
So you have mg cos theta.
Capital MG or small MG, sir?
This is capital, no? Pardon?
No, for this MG, this capital MG or small MG, sir?
So this is do you agree with this? Just like how we resolved mg, you will resolve normal reaction also. Is it clear till here?
Yes, sir.
Yes.
So in the free body diagram of small m, won't there be ma sin theta?
Which ma sin theta?
So then sigma fy equal to may.
No, I am not showing, not that it is there. Not there.
Okay, sir.
Oh, it is there. Followed this?
Yes, sir.
Follow, sir.
Yes, sir.
This is okay.
Yes, sir.
Actually, there will be another normal reaction between these two, no? Because between these two there is a normal reaction or not?
Yes, sir.
Yes, sir.
Sir.
Perpendicular to inclined, no? So anyhow, this is 0. So now we are having how many equations? 1, 2, 3. How many unknowns are there, man?
M. Acceleration, capital, and acceleration.
That's all, no?
Yes, sir.
Cancel those small m, sir. A cos theta is equal to A. You can cancel this A cos theta is equal to A, no, sir.
No, you can cancel. What is it? Okay, this equation is not required because if you take that again, unknown is coming. So if you solve this, you will get A. Agreed?
Yes, sir.
As before, what you got previously, same thing you get. It is only if you want to analyze like this. Now, I am just explaining this because next chapters, just like how vectors are utilized here, we will be using Newton's laws in other chapters. So like that again, we go on adding on one more chapter, we will be having the total grip on the entire syllabus. Connecting that, your engineering syllabus is framed. Tell.
Can we find those accelerations of the loss by components method?
What component method?
Okay, we are assuming that small block is moving right and that capital M is moving down, sir.
Yeah.
So can we do it by components method, sir?
What component is it? Which component only we are doing, no? Blamise theorem, ah?
No, sir, no, sir. Like in the one pulley problem we did, na, sir, by having theta.
Fully problem, theta.
A is equal to A cos theta, na, sir. Like this, like that we can do here.
Constraint method, ah?
Yes, sir.
Hmm? Anything you can do, what is it? Now we should get with respect to ground, no? If you take like this.
Yes, sir.
Now this will be 0, no?
Yes, sir.
Therefore, you can get this also. Understood this?
Yes, sir.
Finished?
1 minute.
Don't solve that, just note down the method I am saying. Yesterday I taught, so the more methods you learn with respect to ground how to do, with respect to the plane how to do. Understood the methods you are following or not?
Yes, sir.
Following, sir.
So if you look at this, what you need seriously is patience. Am I right or not?
Yes, sir.
Yes. Because we have next chapter friction, work for energy, all this needs the concepts of Newton's laws. Just like in your schooling, they just taught A, B, C, D, numbers 1, 2, 3 for 1 year. Now you are free using them now because you are acquainted or eloquent or expertise in using the numbers. So why we are doing so many Newton's laws of problems is they are very much helpful in future lessons. Just like how you are using alphabets and numbers now, you should be capable of using them. Understood this?
Understood, sir.
Yes, sir.
Finish this.
Just a minute.
Yes, sir.
Now you try taking them as one system, Mn and Kaplan. Shall I do?
Yes, sir.
Yes, sir.
Now let us get back to the same thing. See, first of all, if you take this as a system, another way, M plus M as one system. If you consider this as one system, okay? Can you tell what is the force on that? I am taking this both as one system. So the force down the plane on the system will be, do you agree with this?
Into
Any doubt is there?
yes, no doubt, sir.
Now you can see this block is having an acceleration like this. This is what I have taken now. That means this is the incline. Do you agree with this? Now this is theta. Do you agree with this or not? So this is also theta. So now you have to resolve that also. This is A cos theta. What is this? Perpendicular to the plane. Okay, now you have to take, you know already this one with respect to ground, because I want to solve this with respect to ground. So this will be the situation. This is a nothing but the same thing down the plane if I want. Is what is the acceleration down the incline plus down the incline. Do you agree with this? So this is nothing. So you want to know this down the incline and write down. This is nothing but A. This is nothing but down. This is nothing but minus A cos theta upwards, no? And this is A. If I take the inverse as positive. Agreed. Now what I do is, I can say that down the inclined plane I am writing Newton's laws. Down the plane I am applying net force equals mass into acceleration. What is down the plane? The net force m plus 1 d sin theta. Because I am taking this as a system, only external force is this. Agreed? Mass into acceleration of m with respect to ground down the plane plus capital M acceleration of the neck. This is what we need. So this happens to be Down the plane, what you have here, just now you have seen. Understood this?
Yes, sir.
Hello?
Yes, sir.
Yes, sir. Sir.
Should I turn the page?
1 minute.
Hello?
Yes, sir.
Shall I go ahead?
Yes.
Sir, one doubt.
Tell.
Sir, in this equation solving, how should we eliminate minus a, sir, that one?
Which one?
That small a, sir, small a.
I did not complete it, fine. Because I just waited for you to note down. Another equation is needed now. Now if you write in the horizontal direction, actually earlier we got, what is this we have in the x direction? What is it we got? See?
A minus a cos theta.
Okay, so we can frame now. Consider we have, what is the next force? Net force in the horizontal direction is 0. Remember this? There is no force in that, no? On the block, what is the force in that? Nothing is there. Because I am at, with respect to ground, I am taking.
Yes, sir.
Yes.
See, previously also you got this equation, if you want to check up that. Now you observe this, what are the unknowns? A, solve 1 and 2. So if you take that as a system, the normal reaction will not come into role. That is only advantage. So that means number of unknowns will be lesser. Follow this, what I am saying?
Yes, sir.
Sir,
Tell.
how sigma fx is equal to 0, sir?
Hopeless fellow, in the x direction, is there any force on this? That's what I am saying. Use your
No, sir,
mind,
no,
man.
sir. No,
On the
nothing,
x
sir.
direction, this is the acceleration. If you think for a while, you will get an answer. There is no force, no?
Yes, sir.
It, sir.
Got it?
Yes, sir.
Completed?
Yes, sir.
Yes, sir.
1 minute, sir.
Shall I turn there?
Yes, sir.
Yes, sir.
Shall I turn this?
Yes, sir.
So we have done various ways. What are the three things we have done? Considering separately, taking them as a system. Third one is considering the motion of one block with respect to the other three things. Now let us go ahead with almost the same problem, little modification. After this, one more problem, we'll shift this. And if you're confident or you need any basic revision of all this?
Basic revision, sir.
Yes, sir.
Okay.
Basic revision of what, sir?
Newton's law.
No, sir.
What are they? See, again the same story. What is that usually we do? First method is we will consider motion of this. This is the motion of this with respect to this is A. When this comes like this, what will happen? We are pulling this now. So definitely this has
When
to
will
go.
decrease?
Yes, sir.
It
Right.
will be going like this. Do you agree with this?
Yes, sir.
Right. Now we'll draw the free body diagrams of all these things with respect to ground. Now if you can show the forces that are acting on the ground, you can try on the block and all separately. We are having a normal reaction. Let us call it as N1. This is N2. This is Mg. We don't require this. Anything else is there? There is a pulley here. There is a tension. This is the tension. Now if you take some small portion of the rope, see, understand it. If we consider one small part of this rope, say this is Mn, this is the portion Mn. Now if you consider this, on this you are pulling, so there will be a tension developed. Because as rope is massless, tension will be same everywhere, no? Do you agree with this
Yes,
or not?
sir.
You
Yes,
only
sir.
can take
Great,
mass
sir.
of the rope into acceleration. As rope is massless. See, everything minutely I am explaining. Otherwise directly I can take this, no? So this is over.
Yes, sir.
Anyhow, so we will consider this directly. Anything else is there? Any other forces? That's all, no? Contact force, this one, right. Now this is A. If you can, horizontally we need, no? So this is theta, follow carefully. This is theta, this is 90 minus theta, no? So in this direction, what you have? N1 cos 90 minus theta. Perpendicular direction we don't need, I am not resolving. It's not that it's non-existing. Whatever I need, I'll use. Why should I waste my time on unwanted thing? Now this will not contribute for this acceleration. I need this only, no? N2 will not contribute for this. So vertical forces will not contribute for horizontal acceleration. That's why I am not considering the vertical forces. Okay, so here you have Follow this?
Sir,
Yes, sir.
one more f cos theta will come, no?
Yes. That's what. Follow this?
Yes, sir.
Is it clear? Now let us take
Yes,
this.
sir.
Yes, sir.
Now this is having, it is moving like this one, no? So this will be A sin theta. Do you agree with this? Acceleration of small m with respect to ground. As you know, by this time you should be an expert in this writing.
Yes, sir.
Many things you have done. Perpendicular to incline is acceleration of small m with respect to capital M. This is nothing but 0. Do you agree with this? Clear or not?
Yes,
Hello? Wait. This is only in this direction. There is no acceleration in this direction. No? So now you can see, if you take the block, what are the forces perpendicular to the incline? One is the normal reaction, you are getting N1. Next, this is mg cos theta. Any other force is there in that direction? This is the tension on this, but parallel to this we don't need. So this is again, all these forces are there. So now the acceleration in this direction is A sin theta, no? So acceleration or net force with respect to ground, this is writing this perpendicular to inclined plane with respect to ground. I am writing all this. So can you tell what are the forces that will come up? N1 minus mg cos theta equals mass into A sin theta. Understood this?
yes, sir.
Yes, sir.
So now you can see this is one equation, this is another equation. Okay, how many equations are there? 2 equations. How many unknowns are there? F is one unknown. No. We got F. We need F now. F is given. Acceleration we need. N1 is one unknown. A is one unknown. To get A. Understood the question?
Yes, sir.
See, if you observe carefully, everything in this is only based on F is equal to M and resolution. That's it. Follow this. Shall I turn the page?
complete, sir. Yes, sir.
Shall I turn the page?
1 minute, sir.
Finished?
1 minute, sir.
If you look at the books or solutions, you won't get the explanation of this. They'll give one step along this one equation. So instead of understanding, you will misunderstand. So that will have adverse effect in the final exam. See, like this, in a book here, the written is one is printed, you purchase that book. Now suppose you read these together, what will happen? The meaning will change or not?
Yes, sir.
So instead of the correct meaning, you are drawing a wrong conclusion. The problem is that. And suppose you see 64 by 16 is how much? 4. 95 by 19 is how much? 5. So you will see that in the book. You will make your own conclusion that, 6 will cancel 4. 9 will cancel 5. So 70 by 17 you will take it as 0. And you will create your own subject that will have dangerous effect in the final exam. That is the reason why I explain in analysis manner everything. Followed? Always try to understand the concept behind it. Understood this? Why I am teaching so many problems is wrong concepts once they enter your mind, it's very difficult to erase. See, now you are struggling to erase the dirty thing you learned in school, no? Something they'll teach.
Yes, sir.
At that age to get marks, they'll teach men. Their job is over, no? Even for IP, you have to read like how you used to read school only. Some question answers will be there, you'll preparing. But for IIT, that won't work out. Why I am giving so many examples, now they work for me or not? Right. As usual, after this, what is that we do? Suppose we want to solve this with respect to non-inertia, that means small m with respect to capital M. Shall I turn this?
Yes, sir. Complete, sir. Done.
Now let us attempt this problem. which force will come? With respect to this, let us suppose the real forces will show. Any other force? Another force is next. Any other force? There is one more. This is acceleration of small m with respect to m. Any other force? That's all. A checkman with respect to
Yes, sir. Pseudo force.
Pseudo force.
pseudo force. Pseudo force will act in which direction?
Opposite direction of us.
Opposite. Remember that? What is this?
Yes, sir. Minus mg.
Remember this?
Yes,
Hello.
sir.
Yes,
Yes,
sir.
sir.
Now you can resolve this. So in this direction, what you have? This is theta, this is theta. And this will be, understood this? Any other doubt? Anything is missing? Now along this perpendicular to the incline, we can write what are the forces? What is the acceleration perpendicular to the inclination? Zero, no?
Yes, sir.
Sir.
Clear?
Yes, sir.
Yes, sir.
Same equation you got earlier, if you want you can check up. Did you get this equation? Check up.
What, sir?
Followed this?
Yes, sir.
Yes, sir.
Now try to do this by taking that small m and capital M as one system.
Sir, in this problem, we need two equations, no, sir, for n and a.
Which one? Which one?
This problem.
This one. No, you have to frame the other equation. No, you have to frame other equation. It did not complete this. Understood this?
Yes, sir.
Followed this? And suppose you need normal reaction, again you have to consider Because already the two options are over, no?
Yes, sir.
So earlier he got one equation, no? This is the third equation. Now N, A, that's all, no? What else is there? Small a. Tension is only F. F is known.
Given.
Tension.
Yes, sir.
Same answer you will get. Correct. Easy man. Nothing is there in physics. You are making it a hell actually. Patience, patience. Yes, but up to I think till 10th he did not do much physics problems, no?
Yes, sir. Only remembering the concepts and writing the exams.
What
No
concept?
problems.
What concept? And what?
Theories.
Remembering the dirty theory they gave and they are writing the exam, that's all. The main mistake is they left the vectors and they taught physics. Problem comes there. You know that?
Yes, sir.
Shall I turn this? Now let us see the other method is there now. What is that? Considering small m and capital M as one system. Shall I turn this?
Yes, sir. Yes, sir.
These are the usual things we are doing. So now I can the most difficult part is teaching physics. The reason is students don't know anything in school. I think you did not find much difference in math the way you are learning. I am saying. Here also you are remembering some formulas.
No, sir.
Am I right?
In the school, no, sir.
Hmm.
In school, we used to even remember the methods. Same methods used to come in question papers.
That is another thing. Their methods also same.
Problems if we do another method in instance, they will deduct marks.
But that is there for IP also. Right. Now here our aim is to take this as one system. So what is the external force on the system?
F.
Now you know that this is A. So this will be how much? A cos theta, because this is theta now. What is this? A sin theta. Do you agree with this? Now acceleration of small m with respect to ground we need. This is acceleration of small m with respect to this plus acceleration of along x-axis we need but physics is totally new now for you people.
Yes, sir.
Yes, sir.
Understood it? Now we'll apply for m plus 1 m system. mass of this into acceleration of this plus this is nothing but understood this? Any doubt?
No, sir.
Suppose now we need that means this is A, that is A cos theta. Do you agree with this? So here what are the forces? Down the plane I am showing, nothing else. This is the acceleration of mg down the plane. Because this is FBD of small m with respect to ground. Follow this. So what you have here, understood this? Clear or not?
Yes, sir. Yes, sir.
So now you can see that from these equations, how many unknowns are there?
capital A and F. These two only.
Now you can see different ways I tried to explain you, separately treating them as separate entities, one with respect to other. Okay. After that, both as a system. Understood this?
Yes, sir.
Shall I turn this?
1 minute.
1 minute.
ആര് കാണുന്ന് അപ്പൊ ചാവുമ്മ.
Shall I turn this?
So 1 minute.
Sir, considering as a system, so we should take m plus n into capital.
M plus M?
M plus capital M into you should write nothing that accidental whatever it is.
Pardon, I didn't get you, man.
No, sir. In the first step.
This one.
Yes, sir. Yes, sir.
No, because they are not having same accelerations, no? The meaning is force on the system is force on a system in a particular direction with respect to one frame is mass into acceleration of a particle within the system. Okay? In a particular direction with respect to an observer. Individual particles, if both are having same acceleration, I can club them. They are not having same accelerations, no?
Yes, sir. Yes, sir.
Completed, sir.
Pardon?
1 minute, 1 minute.
Completed.
Shall I turn this?
Just a minute.
Fast. No, you are solving, now you don't solve anything. Over?
Yes, sir. Over.
Now, M1. System is in equilibrium. Now string is cut. Right. It's a very easy one. Finish this quickly. So here, before cutting, what is the forces? This is T1. Now the spring is elongated now, so spring force will be driving it like this. Do you agree with this?
Yes, sir.
Yes, sir.
Do you agree with this? Three
Yes,
blocks
sir.
over, no?
Yes.
These are in equilibrium as per the question. Now when string is cut,
So one doubt, sir. So this thing is spring force should be upward, no, sir? Because
no man, the spring is elongated, no? Spring tries to come to the natural length. Think that way. When a spring is extended, the ends come nearer, no? Hello?
Yes, sir.
in straight from nearer, sir.
Pardon?
Sir, but force will be
See,
no opposite.
See, this is a spring, man. Now it goes like this. These ends tries to come nearer, no? When it is compressed like this, they go away. They oppose the compression elongation, no?
Yes, sir.
Understood this?
Understood, sir. Understood.
Once T1 is 0, now you can see as M1 equals 0. So what is the net force? For what? M1. Understood this? Do you agree with this or not?
Yes, sir.
Now what else is there?
Understood, sir.
T1 is 0. T1 is 0 means you have T2. For this block M2, so here what is the acceleration?
SP plus.
Correct?
Yes, sir.
Clear?
Yes, sir.
Actually, this T2 will be, shall I turn this? Okay, I'll draw here. M3. See, when this is cut, this tension will become 0 now. Remember? Because the string should be pulled by something now. When you will get tension, the string should be elongated now. When somebody pulls, there will be a tension. Do you agree with this?
Yes, sir.
Understood this?
Yes, sir.
Is it clear?
Yes, sir. Clear.
Sir,
So, you should be confident with Newton's laws by this time.
and can be negative. Negative
But
value. Sir,
hello, tell me.
sir, can tension be negative? Negative value.
Tension is negative means non-existing. Can your age be negative?
No, sir.
Age can be negative, but at that time we are non-existing. Age is zero means you are just born. Age is positive means you are alive. Understood this?
Yes, sir.
Excuse me, sir.
Now tell me.
I am not understanding what you did in first case, sir.
Which case,
Immediately
man?
after string is cut,
Hmm.
how
This time.
acceleration is 0, sir?
Yes, man. What are the forces? This is 0. For this part, I am saying, no? You take M1,
No,
which
sir.
is M1. This one M1. What you wanted?
No, sir. Right side M1 mass, sir.
This one only.
Yes, sir.
M1G. But before cutting, both are same, no? We can see that.
Yes, sir.
That means upward force equals to downward force. What is the net force? 0.
0, yes, sir. Yes, sir.
So even you got 0. Is it clear?
Yes, sir.
Yes, sir. Clear.
So, hello?
Yes, sir.
Right, with this we have completed successfully Newton's laws. So I have to start friction in the next class. Understood this?
Yes, sir.
Yes, sir.
Right, right. Take care then. Bye.
Thank you, sir. Bye.
Thank you, sir. Bye.
Yes, sir.